Alright, this is a multiple choice question from a non-calculator question. Alright, so it says a table of values for a continuous function f is shown above. If 3 equal subintervals are used on the interval 0 to 6, which of the following is equivalent to a right-hand Riemann sum approximation for the integral from 0 to 6 of f of x? Okay, so we notice that it says 3 equal subintervals, and yet we're given data points from 0 to 6. So if we want to make 3 equal subintervals, we're going to use every other one. Okay, that. Okay, and it says a right-handed Riemann sum. So we are going to use the right points. So in this case, that would be 5, 3, and 4. And we notice these are all equal length. From 0 to 2 is 2, from 2 to 4 is 2, and from 4 to 6 is 2. So we know area is equal to length times width. We're going to pull the width out because it's all the same. So the integral from 0 to 6 of f of x is going to be approximated at 2, which is the consistent width, times 4 plus 3 plus 5. And that will get us 24. There's no calculator, you can just do that in your head. So the answer is D. So this one says the function f is continuous on the closed interval 2 to 8 and has values that are given in the table above. Using subintervals 2, 5, 5, 7, and 7, 8, what is the trapezoidal approximation of f of x, the integral of f of x from the interval 8 to 2? So it defines our subintervals right there. So we're just going to go ahead and use those. And it says trapezoidal, so remember the area of a trapezoid is equal to 1/2 base 1 plus base 2 times the height. And our heights are x values. Notice they're not consistent. The difference between there is 3, the difference between there is 2, and the difference there is 1. So we cannot pull out the height for everyone, but we can pull out the 1/2. So we're going to pull out the 1/2. And then we have difference here is 3, 10 plus 30, those are our two bases, plus the difference between here, which is 2, and then our bases are 30 and 40. And the difference here, which is just 1, times our bases, 40 plus 20. And all of that gets multiplied by 1/2. So we can all just plug that into the calculator right there. I'm going to work it a bit farther first. It's going to be equal to 160. So our answer is C. So now we're going to do a free response question. This is from the 2009 BC exam. This is number 2. And we're given a table. Notice, not a graph. It's usually when they give us a table, it's going to ask for an approximation of some sort. The first thing it wants us to do is it wants us to estimate f prime of 4, which will be the slope in between 3 and 5. So we don't have 4, we are given 3 and 5, so we're just going to take the slope of that. So part A, we're just going to do y2 minus y1 over x2 minus x1. And that gives us negative 6 over 2, which is negative 3. Simple enough. And the next thing it wants us to do is it wants us to evaluate the integral of 3 minus 5 f prime of x. So I'm just going to rewrite it here for you so you can see it better. What we're going to do is we are going to split these up. We're just going to distribute the integral and we can pull out the constant 5 on this one. Okay. And so then we just integrate. So that will become 3x evaluated from 2 to 13 minus 5 f of x evaluated from 2 to 13. So we can just plug and chug at this point. 313 minus 2 minus 5 times f of 13 minus f of 2. So 3 times 11 minus 5 f of 13. We're given that point, so we're going to look say 13, f of x is equal to 6. And then for f of 2, find our 2, f of x is equal to 1. So basically 33 minus 25, and that will give us 8. And part C is when it's going to ask for a rectangular approximation. It says use a left Riemann sum with subintervals indicated in the data to approximate the integral from 2 to 13 of f of x. And then show our work, of course. So it says a left Riemann sum. That's very important. Okay, so what we're going to do at that point is it says use the subintervals indicated by the data. So those are our 4 subintervals. And it says that it wants us to use a left one, so we're going to start by selecting one to the left. Right, and basically, let's just remember that area is equal to length times width. And so we're going to add all those up. So the difference between 3 and 2 is 1. And the left point associated with that is 1. And add the difference between 5 and 3 is 2. And the leftmost point of that is 4. And then the difference between 5 and 8 is 3. The leftmost point of that is negative 2. And the difference between 8 and 13 is 5. And the leftmost point of that is 3. Right, so this is a non-calculator question. So 1 plus 8 minus 6 plus 15. 1 plus 8 is 9. Minus 6 is 3. Plus 15 is 18. Okay, and that is our Riemann sum. Right, for part D, there's a couple parts of this. It says suppose f prime of 5 equals 3 and f double prime is less than 0 for all of x on the interval of 5 to 8. Use the line tangent to the graph of f of x to show that f of 7 is less than 4. Use the secant line for the graph of f on 5 to 8 to show that f of 7 is greater than or equal to 4/3. Okay, so we'll do the first part of that first when we suppose that 5 prime is equal to, or f prime of 5 is equal to 3. So what we can do then is we're just going to write a equation for a line. So let's say y minus y1, we're just going to use the coordinates that we have at 5. So y minus y1 equals f prime, which in this case we know to be 3, times x minus x1, minus our x value that we're given. Okay, and we can just arrange that if we'd like. Not required, we can arrange that if we so choose, that we have y on one side. Okay, well, what does this mean? What are we looking for? We're looking for f of 7. So we want to say f of 7 is equal to 3. 7 minus 5 minus 2. And so that is just 4. Alright. So we know that f double prime is less than 0, because it tells us right here, f double prime is less than 0. And so that means that our whole graph of f is going to be some form of concave down. So just illustrate that, something like that right here. And we have a line tangent to that, which is our f prime 5 that we got there. F prime 5 is equal to 3. The slope of this, there's a straight line here at wherever 5 is, where it's equal to 3. And the slope of this line is 3. Okay. Notice that this is above the graph, so that will be an over approximation. So because f double prime of x is less than 0, this tangent line is going to be an over approximation. So 4 is an over approximation. So from that, we can say that the real f of prime, the real value of f prime, is going to be less than or equal to the value that we calculated in our over approximation. So f of 7 is less than or equal to 4. And the second part, it says use the secant line for the graph of f on the interval 5 to 8 to show that f of 7 is greater than or equal to 4/3. Okay, so we're going to use the same methods we used in part A, and we are going to do y2 minus y1 over x2 minus x1. That will get us 5/3. Again, we just pulled those values from 5 and 8 right here, because that's our interval. We said on the interval 5 to 8. 5 to 8 is what we're using, so we just used those values to calculate the slope, like the average slope between them almost. That'll look a bit different from the other graph we had, because we're using two different points, and we're just drawing like a line through them. So that's more like what our thing's gonna look like. Okay, so very similar equation to what we have in the first part of this problem. All we have is a different slope. So y is equal to 5/3 x minus 5 minus 2. See the difference? Go ahead. Slope 3, slope of 5/3. Nothing else has changed. So let's plug in f of 7 in that scenario. This is a non-calculator, so you have to do some conversions. Just convert 2 into thirds, and you'll get the 2 6/3. And so the whole thing's going to be 4/3. So in the terms of using this line wants f of 7 to be at 4/3. Okay, but what can we tell about this? We can tell that this little secant line right here is under the actual curve. So because this is concave down, the secant line ends up underneath. So because f prime of x is less than 0, the secant will be an under approximation. So really, f of 7 will be somewhere in this range up here on this top curve right here. So we know that the real f of 7 is going to be greater than or equal to 4/3. And that was 2009 number 5.